So just thought I'd
I
quickly,
see it's like the fireworks. We finish with a RAM special where you go through all of
yeah. Well, so I'm just going to go through. This is not necessarily very well. It's not as much backward looking summary of what was done. This is more looking ahead. What are some of my thoughts? And so, I mean, there are a number of topics of current interest in the, I guess, Gen AI and LLM world, which I don't. Not all of this are very well handled and by Onyx standard right now. And I think these are things we probably have to work on. Right. I already mentioned mixture of experts, group MapML, for example. Now, KV cache quantization is also becoming more important, which is also related to quantized attention. They're slightly focused on different aspects of quantization in the attention context. And again, so that is something I think we need to get a handle on. So I list flex attention underneath this because the flex attention was proposed as a way to, for example, represent quantized attention. I'll get into the details a bit later. But some of the other topics, I also mentioned paged attention earlier, and there is multi-head latent attention. Packed attention is another example, which is actually Onyx Runtime has contrib ops to represent several of this, including packed attention, but it's not something in the Onyx standard. Speculative decoding is also becoming interesting. Luckily, I think on the operator side, there is not much impact. I don't think we need to do much to support speculative decoding, but except it has some minor impacts, like in some settings, you might need to support non-causal mask, which I think can already be represented in Onyx attention. So it's, and then rotary embedding for vision models. Again, that's fairly straightforward, but it's missing from the Onyx standard now, and it's something that will need to be added. Taking a step back, I guess one of the things we notice is the primitive ops in Onyx actually suffice to express most of these ideas. So we don't really need to introduce new ops, but fused ops are critical for performance. So, which is why we continue to keep adding these new ops. And I guess a question we have been struggling with, but I don't think we had a good answer so far is, well, if it's for performance, do you really need to introduce this ops, or can backends handle the optimization? Again, input from compiler writers would help, but I mean, the reason for the fused ops has been some of the challenges in actually doing this automatically in a compiler, because you run into this fusion problem trying to identify a large subgraph that implements a particular op. And basically, the fused ops helps the compilers by providing hints upfront. Essentially, that's what they are doing. So, I mean, on the compiler side, there are some challenges that shows up, right? For example, runtime code generation can be forbidden in, in some settings like iOS or Android. And compilers can increase the binary size, LLM. So that's a concern in some settings. Compilation time can be high. We can get around it with our AOT compilation and caching. Finally, I guess the other point is general compiler techniques have not always produced the optimal code. Typically, experts have managed to tweak and produce highly efficient kernels, which are better than what compilers can do. And so I think this will continue to be true. And in an agentic world, it is likely the case that an AI agent, which is likely going to be able to author as well as a very good advanced expert, will be able to write highly efficient kernels. So again, I think this trend will continue even with agents. So which means basically the approach we have still seems to be the right one, that is, which identifying the right high-level composite op to introduce as an abstraction. And then, so I think, so even though everything can be expressed using primitives, I think identifying the right higher level composite ops will continue to be important. So I think the operator SIG will have to continue to introduce the right fused ops, I think.
In those fuse ops, they're functions, right? They tend
Right.
to be function.
Correct.
So they always have a backup with the original, or most of them have.
Correct. Right. So one of the things we have been doing is, right, when we introduce it, we do make sure they're introduced it as functions. So people who don't want this hint can essentially inline the function and get a graph with primitive ops. So, but they serve as a hint. So if you want, you can dispatch it to a pre-written kernel or get the compiler to focus on this as the boundary for a heavy significant optimization. So, yeah. So flex attention, getting back to flex attention, it's higher order op with subgraph attributes. So it's really more an op template than a specific op, actually. So efficient implementation here does require compilation support. What it really does is it helps avoid the need for graph pattern matching. But you still, because it's not a single op, you can't write the kernel for this ahead of time. You would have to generate the runtime. So it's more an interesting idea. It's appropriate for research and experimentation, which is why it's been placed in the experimental domain. It's not in the standard domain yet, because it's not clear what is the right way to compile such things. So other than this, maybe I'll briefly mention a couple of other ongoing work. As a generic technique, I think we can generalize the scan op in a couple of ways. That helps maybe potentially in expressing some of these composite ops. Yeah. Anyway, so I think that's sort of